you can study from there. Unit 1 in chemistry, grade 11, it's about matter, chemical trends, and chemical bonding. We will have to talk about what is matter in general. Chemical trends, I didn't mention it here. I should, but still now I didn't. And the chemical bonding, because it's very important. Our next lesson, we cannot make it if we don't know how to make a chemical bonding. So it's a must. Chemical trends, we can study it now. We can study it after 1 month. It's still okay. It will not affect our way of studying. Some subjects we need it urgent, so we will focus about it. Some subjects that we can postpone till another time, we will work on it later. This is what is going. Matter. What do we mean by matter? Matter is everything is made up of matter. Matter, it's made either we classified it according to elements or according to solutions. Do you still remember? This we said this last time. We said it's either element, made up of element, or solutions. In chemistry, we are talking in chemistry. If we are discussing something else, the discussion will be changed. For example, if it's physics. Elements, it may be atom, individual atom, or molecules. Because element, calcium, is just one element. While hydrogen cannot be by itself. It's diatomic, it's H2. Because of this, we said this is a molecule. It's not atom. Okay? Both of them are element. Why we are saying about them element? Who can tell me why we say about them element?
Because they're in the periodic table.
No, because this is elements. Yeah, are in the periodic table, but this is we say it about it atom. While this is molecule. What is the difference?
Because in the hydrogen there is two, the subscript, which
Yeah.
makes it a molecule, while the calcium is only one element.
Okay, so here the hydrogen is 2 atoms. It's made up of 2 atoms. Okay, and it's a molecule, it's element. It's just made up of one types of elements, which is the hydrogen. Okay, but do you know this is diatomic? For example, we here have carbon monoxide. It's still the same. It's 2 atoms, but here they are different atoms, which we call it compound. Compound. We cannot call it element because it made up of 2 different elements. Oh, we cannot, so we will not save it. Okay. Okay, we have to talk about the compounds. I don't know that we cannot. Okay, so what is the difference between these 3? This is 1 atom, and here it's 2 atoms, 2 identical atoms. One day the atoms are identical, we call it molecule. When the atoms are different, even if biatomic or diatomic, bi or di is still the same, indicates the number 2. But they are different, we call it compound. Okay? It's a molecule, but not made up of the same elements. It's made up of different elements. Trends, anyone of you remember the trends? Okay, what do we mean by trends? Trends is in the periodic table. They say as we going down, the atomic mass increases, and as we going across the table, what will happen? And as we go from left to right, the electronegativity increases. Did you ever hear about this? Radii and electronegativity, atomic size. Did you ever hear about these terms? Anyone heard about this? This is what we call them chemical trends. Okay, so the chemical trends is when we talk about the characteristic of the periodic table, that all the group or all the row or the elements in the same row or all the elements in the same groups are characterized by. Why we cannot? I cannot move it. Oh yeah, when we move it, we have to put in the arrow. Okay, now. Okay, atomic model. What do we mean by atomic model? How to make the atom? The atom is made up of what? And how they started? For sure, they didn't start knowing that the atom is made up of a proton, a neutron, and an electron. They didn't start this way. They start thinking that the smallest atom, the smallest particles of the matter is atom. Atom means it's unable to break it anymore. This is the meaning of atom. Okay, so they just brought this antimatter and they break it into two and then into two, then into two, till they were unable to break it anymore. Okay, so they said this is the last one, we call it atom, which means unbreakable. We cannot break it anymore. So atom mean we cannot divide it into anymore. And they thought that this is the last part, that is the smallest particle of the matter is the atom. Later on, they start to say, no, not the atom. The atom even itself is made up of subatomic particles. Okay, so if the matter made up of particles, we call it the atom. The atom itself is made up of subatomic particles, and we will see how they start to discover it, how they start by Dalton, and then Thomson, what they said, and then Rutherford, what he came to say. Okay, our current model of the atom, the quantum model, we call it, wasn't developed overnight. So they didn't know it just by one night. They studied it a lot, and they did many experiments till they discovered what is going on. Dalton's model. What did Dalton say? Okay. Did you ever hear about Dalton's? Anyone heard about Dalton's? Okay.
No,
Dalton's, do you know? I don't care to know all the information. I just want you to know that Dalton's is the one who states that all elements are made up of atoms. Okay? All elements are made up of atoms, okay? And it's impossible to divide it or destroy it. This is the smallest, okay? So they think that everything is just made up of atoms and you cannot divide it anymore. But later on, we discovered that atoms can be made up of small particles, which we call it the subatomic particles. All atoms of the same element are identical. Can you give me example, please, about this? Give me example about this. I just mentioned it a few minutes ago. So he said that the matter is made up of elements. Any element, if we break it, it will be end up by atom. And this atom, we cannot break it anymore. And he said, if we, for example, I have papers, all these papers are made up of the same element, which is the paper. So they are identical. If you look at your notebook, all the papers are identical. But if you look at the papers that you have and at the cups around you or whatever beside you, or the pens, for example, because you are students, have pens a lot in front of you, the pens are made up of a material and the papers are made up of different material. Is this right or not? So this is what does he mean, that all atoms of the same element are identical. Can you give me just please example about elements that are identical? Atoms made up of same elements are identical. And he add here the same sentence, atoms of different elements are different. What does it mean? For example, if we have hydrogen, and I have another hydrogen, and I have another hydrogen, these are atoms of the same element. For example, this is hydrogen 2, and this is hydrogen 2. This is element, okay? But it's made up of 2 atoms. So the atoms that this element made up of are the same, okay? Because at the end, we said we have a piece of a matter, we keep divided till we get the end. But all of it made up of the identical. For example, I have this paper, and this paper is carbon, 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 carbon. If I divided it, I will end up with only 1. But all this paper is made up of identical atoms, which are carbon. Okay, did you understand? Okay, while if I have this band is made up of another material, let's say, for example, lead. Okay, this is a lead, this is lead, lead, lead. We are going to divide it. So this is made up all the atoms that this pencil is made up of is lead. And this paper, all the paper atoms are made up of carbon. So, but this is different elements, okay, have different atoms, are made up of different atoms. Is it clear or not? Okay, atoms of different elements are different from each others. Okay, atoms of different elements to combine to form a compound. I have here, for example, carbon, and have here lead, or I have carbon and oxygen in the air. When they combine with each other, they will give me carbon oxide. Or when oxygen combine with hydrogen will give me water. So when different atoms combine with each other will give me different compounds. So when oxygen combine with carbon, it will give me a gas, which is carbon monoxide. But when oxygen combine with hydrogen, it will give me a liquid, which is water. Okay? Are you understanding or not? Hello, Bob. Hello, guys. Are you here?
Yes.
Are you
Yeah,
understanding?
so far, yes.
Yeah.
Yeah.
Okay. Atoms of different elements combine to form compounds. So the atoms of different elements will come with each other to combine and give me compounds. Chemical reactions occur when atoms are separated, joined, or rearranged. So what is the chemical reaction? That I have, for example, here, calcium oxide. This is compound, atoms. Here I have atoms and here atoms. And I have here sodium nitrate. What will happen that this is separated, okay, and rearranged. And then the calcium will come with the nitrate, and it will give me calcium nitrate. And then the sodium will go with the oxygen and will give me sodium oxide. Did you understand? So this is what we mean. Chemical reactions occur. This is, we say here, I have a chemical reaction. When atoms are separated, here the atoms in the reactant sites are separated and then joined here or rearranged. Whatever will happen for them. So this is a chemical reaction. So let's see some experiments, as he says, to see how they discovered. The discovery of the electrons can, and a few here. Cathode rays is did by Thomson. Thomson, who is the one who said that we have this structure. Okay, let's of a plumb putting model that the electrons and the protons are distributed in the atom this way. Okay, but now they will come to say no, that wasn't true. He used this method, the cathode ray method, and I don't need from you to say to to discuss the experiment, and I didn't mention here the experiment, how it took place. So they are discovered, it's in neutral. They discovered that they are in neutral because there are positives and there are negatives. So we have both in this atom, the positive and the negatives. Because if they said, no, the atoms is not made up of electrons by itself. It's made up of electrons and the protons that are the same quantity, are balanced, and my atom is in neutral. You need from each one just to know what they said, the small, not everything. Changing models. Okay, so here Rutherford said no. It's not look as Thomson said. Thomson said that they are distributed everywhere. Do you still remember the structure? He said, do you see that plus, minus, or it's not 1 plus 1 minus, but they are distributed everywhere. But Rutherford came to say, no, this is not true. They are not distributed this way. The electrons are on the outside and the protons are inside. Because he did another experiment, which is the alpha experiment, and when he was sending rays, they was hitting something. If you see here, the rays that he sent it, if they coming into the center, they reflect. But when they go into the boundaries, they go inside. So this is let him discover that at the center, it looked like that we have a solid, and this is where the protons are accumulated. So he came to this discovery. But even though they came after him, they said, no, not true. After him, they come to say, no. Bohr said, no, this is not true. That when we did another experiment, he recognized that the electrons are not in the same levels. They are not accumulated just like this. He found that they are accumulated like this in layers. And he said we have shells or levels, and that the neutrons and the protons are inside the centers. So everyone just added. Bohr is who the one discovers the shells. Okay, Rutherford, he said that the protons are at the center. Thomson, he discovered that we have protons and the neutrons. So every one of them discovered just one thing and added. And when someone comes with a new discovery, so the old experiment will be cancelled. And at the end, if you recognize here, they helped us a lot. Bohr said that we have levels, and Rutherford said that we have protons and neutrons at the center. And so they agree with each other's, and they came with this structure. Okay, so protons and neutrons are inside the nucleus, and electrons are moving around in orbitals or shells. Is it clear till now? Is there any question? So this is how they start to develop how is the structure of the atom, and where the electrons are located, and where are the neutrons and the protons are located also. Okay, and what is the charge of, and they even discovered by these discoveries what that the atom is in neutral. This is how it looked like. Okay, and if you look like just there is something, we studied it yesterday. What is it? That we have a neutron, that we have a proton, that we have electron. Can one of you tell me what do you recognize here? What do you see? It's an atom. It's atom. So it didn't lose any electrons. It didn't gain any electrons. So what do you see?
It's an electron, and in the middle it's a proton.
In the electrons is in the shells. Okay.
Yeah,
So they are moving.
the proton.
Okay, and the
nutrition.
So what about the number? What
It
about the
should be
number?
inside.
Huh?
Should be inside.
What is should be inside?
The number.
No, this is already, this is the proton, okay? And this is the neutron and this is the electron, okay? So this is in general my x, okay? I don't know which element is it. Can any one of you discover which element is this? Okay, can you discover which one? We have to predict by using the periodic table and the information we have here. So let's discover which element is this in the periodic table. How many electrons does it has?
Only 3.
3. What about the number of protons?
Also 3.
Okay, that's which means it's equal. If the number of electrons is equal to the number of protons, what do you recognize? Is it atom or ion? When number of electrons equal the number of protons, what we can say about this? Is it atom or ion? This is mean they are equal. This is mean that it's still atom. Okay, this didn't lose anything or gain anything, because when the number of electrons will be greater or smaller than protons, this is mean it's ion, it's lost or gained. So this is atom. Is this right or not? Number of electrons is just equal to the number of protons in one case if they are atom. Okay, who can work in this and deduce A and Z? Please, I want you to find A and Z. How much is the Z?
The Z is the atomic number.
Yes, it's the atomic number. How much is it? There is another hint we get it about Z, that it is always equal
To the numbers of protons.
Yes, yes. Z equal to the number of protons. I don't care if it's atom or ion or whatever. It's always Z equal to the number of protons. How much is the number of protons?
It's only 3.
Yes, so it's 3. If I go to my periodic table, do you think you are able to identify this element? Abbas, can you go to the periodic table and check what element is it?
Yeah, I'll check right now.
I don't have it here. Abbas, go please also.
Sure, give me a second.
Yeah.
I think it's lithium.
Very good. Yes. It's lithium. Its post is in the its number is 3, so the third box.
Alkali metals.
Alkaline metals. Can you just tell me what is A, but without looking at the periodic table? A equal what?
Is it the number of neutron and proton?
Very good. The number of neutron and the proton together. Abbas, are you understanding?
Yes, I got the scores.
Yeah. And because when I was calculating the N, I was saying it's A minus Z. Do you remember? I was saying every time that A equal sorry. I was saying N equal A minus Z. Do you remember this? And at the end, Z is the same number as the proton. Okay? So how much is the N? How much is our N? How many neutrons do we have?
Have only 4 neutrons.
Yes, we have 4 neutrons. And
3 protons.
and 3 protons. Very good. So total 7. Can you please check in the periodic table? How much is in the periodic table?
It's like 6.9 something.
Okay, but I said we can
Yeah,
change.
around it. Yeah.
We cannot change the Z. Okay, it's approximately because we don't use the decimals. Okay. Here. Okay. Suppose I don't know that it's silicon, or let me know. If even I know silicon, this is my X. I want you from the given to give me how much is A and how much is Z. Okay, let's look at it. Here it's not X, it's silicon because it's known. The element is known. I want just to identify the number of A and Z. Number of protons and number of neutrons, okay? In the nucleus, which means the number of protons and neutrons are equal what to what? Okay, what are they represents? A. Do you remember? Do you still remember here? Proton and neutron, proton and neutron. So this mass, okay, what is inside it is represents A. Represents A. Okay? Are you with me?
Yes, we're with
Yeah.
you.
So this is what is inside the nucleus represents A, the mass number. Okay? So we will go to this exercise and see. How much protons? We have 14. How much neutrons? We have 14. So now, Abbas, it's your turn. What is our mass number? Our mass number equal what?
Equal the electron.
Equal what?
Electron equal the proton here.
Electron equal proton. No, I am asking about A, which is the mass number. Okay?
I will.
A, look here. We said here A equal N plus P.
Can I answer the question?
Let him try, because I know you said it before. Okay? What Abbas? So A equal what? Equal proton.
Proton plus the proton plus electron.
No.
No.
No, it's plus Yusuf.
So it's protons plus neutrons, which give us 28.
28, which is, I just said here, I said, do you see what's inside the nucleus? Is the proton and the neutron. And this is resemble A. because
Okay.
H equal neutron plus proton. Okay?
Okay.
So here, I know it's 14, as Yusuf said, plus 14 equal 28. Okay? And if so, I have now my A, which is the 28. I need now to know my Z. Z equal to what? I know Z equal to proton. I cannot say Z equal to electrons. You cannot say it. Even though electron equal to Z, to proton. But in which case? You have to say between brackets in case if it is atom. This E equal B is conditional. What do we mean by conditional? What do we mean? Why we say condition? Atom. Because if this is ion, electron will not be equal to proton. The electrons will not be equal to the number of protons. Electrons equal protons only in one case. If my element is an atom. Okay? Abbas, from the given graph, how many electrons do we have?
We have 14 electron. We have 14 electron.
We have 14. How do you know?
It's should be like protein or proton is equal to electron, and also like is here on the graph.
In the graph, what I see, look here, 1,
Yeah,
2,
on the
3,
graph is
4. This is the second 8, and the last one contain 4, so it's 14. Okay?
yes.
Okay. Here he said this is not related to this graph. He said the number of electrons in the orbitals in general. Okay, it's 2, 8, 18, 32. So this is different in what I said last time. This is contradict what I said. I said 2, 8, 8, 2. Do you remember, guys? Because this
Yes, I do remember.
yeah, this is for grade 12, and for grade 10, we use 2, 8, 8, 2. We don't use these numbers because here we use it when we use the electron configuration in terms of SBDF. Okay? So this is correct, and that one is correct. Because we are in here now, we will just use the electron configuration till Z equal 20, till calcium only. The first 20 elements. We cannot use it more than the first 20 elements. Okay? So now, is it clear? Now we have to make application. Do you see this? Here, the elements, he gave me the name. Here, I like this mostly. This one, I want Abbas to do it. This is the, because he need to use the periodic table to figure it out. So the first one, please, Yusuf, do it. The first one is a little bit okay, but
Sorry, which one?
the first one, the first line. I am in, you see my screen, so you know where I am.
Yeah. Is it the symbol C?
Yes, the same symbol C. C is what?
So it's carbon.
Yes. So I have to name it. Can you write?
Right on the screen?
Yeah,
No, I don't think so because only you can because you're sharing it.
I will. Okay. I don't want. Abbas Dul Hussein. I think I gave you. You are not allowed because of the setting. Okay, so I have to change in the setting. I will not go now. Next time I will give you the permission.
Okay, sure.
Okay. So here, just tell me and I will.
So the name of so it's an atom.
Atom, it's carbon. Good. Then,
And the atomic number is 6.
okay.
And the atomic mass is 12.
Just let us understand. Here,
Oh,
the
sure.
symbol is seal. Atomic number, how much is it?
It was 6.
How did you know?
I was just on the periodic table.
So you use the periodic table because there is not enough information.
Yeah.
Okay? So the carbon is above how much? 12 and down 6.
Yeah.
Okay, so Abbas, do you see? He wasn't able to figure out them. He used the periodic table. Some of them we can figure them out without go to the periodic table. Okay, so the atomic number
It's 6.
6 because it's the Z, yes?
Yeah, it's a Z, and the atomic
Mass number,
mass number is 12,
very good.
which is the A.
Number of protons,
So no, I think it's 18.
how?
I think because we do 12 minus 6 equals 6. Okay.
No, this is the neutrons. 12 minus 6 is the neutron. Okay?
Yep.
So number of protons is 6. Why? Because P equals Z. Please write some notes. Next time I really want to know that you are writing some notes. This is B equals Z. Here, number of neutron A minus Z. Okay? Number of electrons E equal B إذا if it is atom. Okay? If you recognize here, I just write the letter directly and the number. And here, directly, I knew it because it's just I figure it from the given. But that one, I need some calculation. I need to know that proton equal to Z. And here I have to find the difference between A and Z. And here I have to say electron equal proton atom. Okay? Is it easy or not? How much is it here? Electron equal proton equal 6. Okay, Abbas, do you want to do it now? Your one?
Yeah, I can do it. I can give it a try.
Okay, please.
Okay, so 16 on the big table is it's sodium, and the sample is gonna be the S. Um
Wait. Magnesium, what is the symbol of it?
oh, okay, so yeah, I jump for the next one, the one you told me to do it.
Okay, that's good. Okay, so here atomic number is the Z and the mass number is the H. Okay, so how you are going to figure it out?
Can I do the first, like the sodium, then I gonna do the magnesium?
Okay, do you know here you know the atomic number is Z. Is this right?
Yes.
What is equal to Z? What usually
Okay, so yeah, let me try with this. Okay, so is the atomic number is gonna be the 25.
25. What is 25?
No, give me a second.
Wait,
So it's
Abbas, listen to me.
okay.
Here I have the atomic number, which is Z. Okay?
Okay.
I know that atomic number means that. And I know this is A and this is Z and Z is here. Okay? So
Okay.
tell me, according to the information that you have, usually Z equal to what? What we can deduce from Z?
So it's a protein, proton.
Proton, Z equal to proton. So we have to fill here. So it's equal to protons. Very good. Okay.
Okay, so
And,
it's
and
yeah.
also our protons is equal to what?
A proton plus the nutrition. So it's gonna be 16 plus 16. So it's gonna be 32.
What is this? Proton and electrons. A proton and a neutron is 32.
32.
So it equal to what?
That's equals A.
Very good. This is my mass number. And then?
Yeah. Number of electron is equal the proton, so it's gonna be the last one, 16.
Very good. So you have, if you are going to your periodic table, which number will help you? Which number is gonna help you?
It's gonna help me the 16.
Which one? Don't say the one of the electrons. This is wrong. Okay?
No,
Even it's 16.
The atomic number?
Yes, it
Atom.
should be the atomic number. So you have to take
Yeah.
this and go to the periodic table and find it. What
Yeah,
will
it's gonna be the sodium S.
sodium?
Yeah.
It's not sodium, it's sulfur. Okay?
Silver.
Sulfur. So sulfur, and it will be S32 and 16. Why I said 32?
Because it's the mass number.
Yes, because it's the mass number. Yusuf.
Also the A.
Yeah. Yusuf, it's your turn now, the magnesium atom. And I want one of you to figure out how to write the symbol of magnesium.
So the symbol of magnesium is Mg.
Very good. How did you know? Then why not Ma?
Because they took the third letter, which is Mg.
Yes, because here we have more than one. We have have manganese and magnesium.
Yeah,
Because
manganese is with the Mn.
yeah. So
Because
here
it has the
magnesium.
letter N.
This is magnesium. And now we have A.
So
Oh. From A, I cannot. Can we? I need help.
no, we have to look at the periodic table first.
Very good, very good. I need at least Z or at least N to figure out the others, okay?
So I have the Z with me. It's
Yeah.
12.
It's a 12. And then?
And the mass number is 25.
Yeah, it's given.
And the number of protons is, again, it's 12.
12.
And the next one is 13, because when we minus A minus Z
Very
equals
good.
13. And I'm not sure about the last one.
It's the
Is
number of
is it also 12?
Yes, it's also 12. Okay, the last one, it will be for Abbas, and the one before the last, it will be for me. Okay? So the last one, please, Abbas. It's sodium ion, and as if you recognize this is sodium. The first name for it was natrium. It was Latin name. Okay, before they changed it to sodium. Say it was started by Na. Okay? So this is why sodium is Na. It's not So or Sd. Okay? Because the first name, it was natrium in the Latin names. Okay? So now can you figure it out? Please. Can you figure out anything now? Are you able, Abbas? We just have the neutron. We cannot. Can we deduce
For the sodium, so
Yeah.
sodium ion?
Yeah.
Yeah, I think I can. I can give it a try. So, okay, give me a second. So it's here on the big table. I can see is the And A is gonna be the number of, or is it? Is it 34 or it's not? No.
23.
Sorry, let me just double check it.
It's in column
Is
1. It's in column 1.
and so it's not the 32.
The most important now to find is that
Okay.
in
Trying to find it.
column 1, in column 1.
Look, column 1. Okay, so
Hydrogen,
it's 11.
sodium.
Yeah,
It's what?
11. The atom.
Yeah.
Okay, so it's here. We figure out
And
is the
what about
Z.
the mass number?
Mass number gives us. It's gonna be 22.
23.
23.
It's given 22?
It's 23, yeah. It's
Yeah,
22.99.
yeah, because I told you that we use it approximately sometimes because there is average. That one is the average. Okay.
Okay.
I maybe for
So-
this periodic table, for this PowerPoint, if you are doing well, I will add how to find the average atomic mass because it's important. I removed this slide that related to it because I didn't see that we are able now. Okay, so now atomic number. What is the atomic number?
So the atomic number is gonna be 11.
It
That's
will be
correct.
11.
And the mass number is gonna be the proton plus neutron is gonna be it's gonna be 23.
Okay, it's 23. If I have the Z and the and, but here I have it. It's given 23. It's at the top of sodium.
Okay, it's already there.
Yeah.
Yeah, and
Number
and
of
here is gonna be 13. Sorry, it's 11.
yes.
And the last one is gonna be the electrons. It's gonna be 11 as well.
Yes, very good. And that's all. For the last one, it will be sulfur. I will change the color. It will be sulfur because already you did it here. If you recognize, somebody did it. If it's atom or if it's ion, I don't, there are some things will never change. Everything is the same except here. The electron will change. If I have atom or ion, still everything the same except the number of electrons. Do you see this is sulfur? Yusuf, you did it, the sulfur, yeah? No, Abbas. You did the sulfur. And you said the number of electrons is 16. While here, I say it's 18. Let's figure out why. I will copy Abbas. I will not bother myself because I know the Z is still the same. The number of protons is the same. And the number of neutrons is the same. Do you see, Abbas? I copied you. Because it will be the same.
Yeah.
Nothing will change. What will it change? The number of electrons, because it's outside. Okay? If you have you have a house and you close the door, and you have just outside a chair or flowers, the one who will pass by your home can't get the flowers because the door is closed. So we cannot touch the neutrons. We cannot touch the protons. Okay, and the place of the house will still the place of house, which is the Z. Maybe the postman will come, so he will give me some mails. Okay, so he will add to me. Here, look at S minus 2. This is mean that it gained 2 electrons. It gained 2 electrons. Okay, When it's negative, it means it gained. How much it gained? It gained 2. Okay? It was how much? 16. And gained 2 electron. How much it is now? How much is it now? 18.
18.
Yeah, because it gained 2 electron. Okay, I will write now for sodium. Let's play now. Sodium. Sodium plus 1. Who did sodium?
I did.
Okay, so tell me, how much is the number of electrons?
So the number of electrons is gonna be 10.
Very good. Why?
Yeah.
It lost. Okay, now
Plus 1.
carbon. It's carbon usually -4 plus 4. Okay, it's either plus or minus, so it's not stable. And we rarely find it, the number of electrons. But let's talk about magnesium. Magnesium is 2 plus. So, Yusuf.
So when this means it lost 2.
Yeah.
So now it's Ca10.
Very good. Its number of electrons, it will be 10. Did you understand? Okay.
Right.
Is there any question now? Do you have any question?
No, thank you.
Okay, so you can take a screenshot for this before we move on. Because when I close my PowerPoint, I will not save this because I will lose my PowerPoint.
Are the slides available like on
The
Google
slides are
Classroom?
available. Yeah, it's a copy. It's available in
Google Classroom?
Classroom. It's the same one.
What about the answers? Are they like there or?
No, if you want, I will add the answers.
Okay.
Do you want me to add the answers?
Yeah, it's better than like
Okay.
blanks.
Because it's not look like us. Okay, I will add the answers.
Okay, thank you.
Okay. Why it's not work? Okay. Oh, we have to delete all this now. I don't know why it's stuck them. Before usually it wasn't. It's depend. Some things I don't know how to make it. To be honest, with technology, some types of pens you just stay in the same page. Others, as this, it comes with you to others pages. How things are going, I don't know. Standard atomic notation. Notation. What is the meaning of it? This is our notation. Okay. This is what we call it, the notation. Okay. That is oxygen. This is the Z and this is the A. Okay. Mass numbers, which is what? A is equal to protons plus neutrons. This page should be the before. I should change this page and I'll put it here before this. Okay. We have to discuss this first and then come to the PowerPoint, to the table. So already we worked on it. Do you remember? We did everything and already we discussed it the last time. Okay, we are going to finish. Ions. Look at it. This is -2. Okay. This is the structure of -2. Who can tell me this is X? Okay. What is the Z? What is the Z of it? Abbas.
It's 8.
Very good. Tell me about the A.
The A, it's give me a second. It's A16.
It's 816. Tell me about the number of electrons.
It should be 8.
No.
2.
No, it's 10.
8.
Look at it.
10. It's here 10. Oh, because the -2, sorry. I
No, you don't. No, you don't count the -2 because you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what I have to write here between? I didn't write, is it equal to the proton? Do you see the proton is 8? Ah, you mean that you have to add to it. Ah, you are getting it from the proton. And I'm getting it from the electrons because already the electrons are in front of me. I got it, you, Abbas. You want to say that we have 8 proton, which
Yeah,
means,
that's why.
and you added 2. Yeah, but these electrons, and when it's equal to 10, is it atom? I have to write here atom between the brackets, or ion?
It's ion.
Very good.
So like when you say like atom and ion, like what exactly you mean?
Atom or ion?
Yeah, like when you say atom or ion, what do you mean?
When proton equal electron, okay, this is mean it's atom.
Mm-hmm.
Okay, look here, how many protons? 8.
We
How
have
many
8
electrons?
electrons.
How many electrons?
We have 10.
10. So the electrons, protons are not equal to electrons, so it's ion.
Okay.
Okay, this is
Okay.
mean that it's charged. What this is mean it's charged? It's a change its structure, it's change its appearance, it's want to be look like the noble gases. Okay, so now it's look like somebody, an element in the noble gases. Okay, because
Okay, thank you.
everyone in the elements look like the noble gases. Now the other one, who wants to make this the other one? Yusuf.
I can't.
Mm-hmm. So the numbers of protons, we have 3.
3, which means that, okay, and
Mm-hmm.
A
And
power,
7. 7 is the mass number.
and electron,
And the electron, we have only 3 electrons. Sorry, I mean 4.
very,
Is
no,
it? Oh, I mean 3. Sorry.
electron does not equal protons because it is ion.
Yeah.
When we
But,
have a charge, it's ion.
yeah, but we have 3 electrons. That what I was trying to say.
Yeah, we have 3 electrons. No, it's wrong. It should has 2. Okay, why it should has 2? This picture is wrong. It should me look like helium. Helium has 2 electrons and should lose this one.
So we must change.
Yeah,
like,
yeah. I have to remove this. This is wrong. Okay, so I have to write for myself note. You know, when you know very well, you can discover the mistakes. Beige. To change it. Okay. Why it's wrong, Abbas?
Because it's giving 1 electron, so it's not gonna be 3. So it's gonna be, instead of 3, it's going to be 2.
Yes, because the number of electrons doesn't equal the number of proton.
I was a bit confused. That's why I stay quiet.
Yeah, so it's wrong. Okay. Subhanallah. When you know things very well, so you can say no, there is something wrong. Okay. Okay, so here. Is there any question? Fluorine. What charge would be the following atoms have when they become ions? Fluorine. Tell me how to write it. I will write fluorine. What is the charge of it? Okay. How to write the charge? Simply this number, -1. Okay. Let me go back here. Do you see this is? Okay. What is ever? What is the charge of it? What is the charge? This one, -2. Here, the charge is +1. Lithium +1. Okay? We go to this. Aluminium, what is the charge of it?
+3.
+3. Because it lost 3 electrons. Calcium,
It's +2.
very good. Phosphorus,
-3.
okay. Yusuf, which element here lost electrons?
So lost electrons is aluminum and calcium
Okay.
because they're
Abbas,
positive.
yeah. Abbas, which element gained the electrons?
Oh, it's the calcium.
This is fluorine and fluorine. This is gains. These are gains. This is lost. Okay. Even though when I was students, okay, when I see plus, I feel it's the winning. And when I see minus, and my mind, it's mean the losing. Okay. But here, no. Minus, it's mean I gained electrons, which means gaining. Because at the end, what is the outermost shell has? Electrons. So when I have negative, this is mean it's not the negative plus and minus as in math. Here it's mean I have 3 electrons more. Okay, so which mean I gained electrons. Here it means I have 2 protons more. This is mean that my electrons got lost because the protons is more. My protons is more. This is mean the electrons got less. So I lost electrons. Okay, do you understand this concept? It's not easy to understand it if you cannot just memorize it. Negative mean that we gained electrons, while positive mean we lost electrons. Okay? No one will ask you here about the concept. Mass spectrometry, this is a run. I don't need this one to explain it. Let me see the last one, isotopes. Do you still remember the isotopes? What do you mean by isotopes? What do you mean by isotopes? Do you have brother twins at home? Who has brother twins at home? No one? Me too. I don't have. No, I don't have any brothers. But when I was in the school, there are 3 girls which are twins. Okay? Everyone, they have the same house. The same house. They go back to the same house, the same building, everything, the same box. They are identical. But each of them has here a different mass number, which has her own name. Okay? You see here? They are hydrogens, but this is plutonium, this is deuterium, this is tritium. Okay? This is mean they are twins. But we don't use the term twins in chemistry. We use another term, a chemistry term, which is isotopes. Isotopes mean they are identical. Okay? And when they are identical, what can you give me a definitions? Look at them. What they have the same? Same what?
Same Z number.
Same atomic number. And different?
Different atomic mass.
Mass number. We are talking about numbers here. And different mass number. Do you see? This is the definitions. You created by yourself. Okay? So they have the same atomic number, but different mass number. Abbas, look at the picture here. Okay? What they have the same? What they have the same?
The same proton. They are showing
Yes.
the same proton
And different?
and different number of the element
Neutron.
or neutron, sorry.
Neutrons. Okay? So if I want to, I can get this another definitions. I have two definitions. Isotopes are elements that have the same number of protons but different number of neutrons. Or, as Yusuf said, atoms are elements that have the same atomic number but different mass number. Is it clear? Is it clear?
Yes.
Yeah, because
Yes.
here, look at it, 1 minus 1 is 0 neutron. Here, 2 minus 1 is 1 neutron. 3 minus 2 minus 1 is 2 neutron. So I get it from here. But if I just will look at the symbols, I will say same atomic number, different mass number. If I will look at the structure, it's same number of protons, but different number of neutrons. Okay, so we finished our first periodic table. Is there any question? You have to focus about the definitions of isotopes, and you have to focus about how to write the symbol of ions and the symbol of atoms, and also you have to find the subatomic particles of an element, which is the proton, neutrons, particle, electrons, mass number, atomic number. You have to find all this. Okay, and in general, from the periodic table, I will, if we say, ask you, the one who discovered that the protons are located at the middle, at the center of the height. So you have to know that it's a Rutherford. Okay, it's just you have to know the most important regarding each one. Okay, not memorize everything, just the most important of the discovery of each one of these. Okay, you can go back to it at any time. Any question till now? Now I will go to second periodic table.
Okay.
Let's see how much we can. I didn't share the screen. I forgot. Okay, do you see my screen? Are you
Yes.
here? Okay.
Yes, I
So
do.
this is the chemical names and formulas. I will see how much do you know. This is what we have. We are going to study general information, binary ionic compounds. Binary mean 2. Ternary mean 3. We call 3 or polyatomic, which means that it's made up of 3 or more. It may be 3 or more. If it just has 2, it will be here. Naming metals that have one more than charge. Transition metals. You know? This is in the middle. We will study how to give it name. The molecular compounds, naming acids. Okay, let's see. So this is the periodic table, the same one that I shared with you. So here the first column is the alkali metals. If do you see here? No, it's not the one that I shared with you. This is one to give you the names of the metals. Is it the same one? No. This is the name of the column. Alkali metals, alkaline metals, and the halogens and the noble gases. And here are the transition metals. Is it clear?
Yes.
Yeah, so we'll go. And this is more clear. Alkali metals, alkaline earth metal, transition metals. This is pure metals, we call it metalloids. And the others is non-metals, halogens, noble gases. And I care mostly, I want you to memorize, you have to memorize this. And this
What is actinide metals?
actinide metals, this is metals, do you see this here and here?
Yeah.
Yeah, all are here. All are here. They have the same Z. Usually they have the same box, but different properties. So from here we get them. There are metals from the name of it. Actinide metals. This is here. We have AC, and all this is related to this family. but we rarely use them. Okay?
Do we need to know like the place of them,
No,
or it's
no,
not important?
no. But if you saw it, at least you recognize where is it. Okay? So you know that this is here in this location. Okay? But
Okay.
mostly I told you these 5 you have to memorize. You have to know their names.
Yeah, I already memorized these 5.
Yeah, because we should. Metals and non-metals. And he here just telling you where are the metals. The metals are these and the non-metals are this is semi-metals which mean metalloids. And this is our non-metals. Okay? This is a stairway of division in the periodic table. This is the stairway. What above? It's non-metals. Okay? Oh, I changed. It's okay. I will not. Ions. What do you mean by ions? Ions, we have atom. If lost or gain electrons will be an atom, will be an ion. Okay? Did you understand what is the relation between atom and ion? Do you know? When atom lose electrons or gains electrons, it will be ion. Okay?
Okay.
But are all the ions positive? No, some atoms, ions, are positive and others are negative. And here are positive. If they are positive, we call them cations. And if they negative, we call them anions. If they have positive charge, we call them cations, as sodium, calcium, lithium. Okay? Anions has negative charge as chlorine, fluorine, iodine, carbide. These are also, we call them negatively charged. We call them anion. Is it clear till now? Is there any question? Guys, are you understanding?
Yeah, so far so good.
Yes, yes, it's
Okay.
clear for me.
Okay, here. There will be a nice trick that help us to know what is the charge. So we will go back to the periodic table here. If it's here, group 6, do you see? It's a group 6, so it's 2 minus. I can give it directly. If a group 7, it's -1. If a group 3 here, so it's a +3. If a group 1, it's a +1. If a group 2, +2. So do you see? I know them. Any element, give me any element. If you told me titanium, okay, that's good. It's Ti3+. If you give me iodine, I will say it's okay, I -1. Okay? Did you understand why? And this is -3. So from here to here, -1, -2, -3. From here, +1, +2, +3. Okay? So I will ask you, Yusuf. Yusuf, give me the symbol of this ion. Ion, not atom. Because as atom, it's Fr. Ion,
Which element?
Fr. This one
Oh,
I
Fr?
circled.
It's +1 because it
Yeah.
loses 1 to be stable.
Yeah, so it's in group 1.
Yeah.
Abbas, I want you to give me gallium. The symbol of this ion.
Sorry, I didn't hear the last 2 words. Like the connection was a little bit bad for me.
Okay. I am asking you, can you give me the symbol of gallium?
Of what, sorry?
Gallium, here, this one.
So it's gonna be the gallium. It's gonna be is the 31 or plus 3 gallium.
It's gallium 3 plus. Why? Because it's in the group 3.
Okay, in the third group.
Yeah, because it's third group to the left, so it's positive. What if I want from you nitrogen?
Nitrogen, okay. Nitrogen, where is the nitrogen? Okay, it's here, the nitrogen. This is gonna be the fourth group.
No, it's the third
Here.
from here. It's the third from here. Here, -1, -2, it's -3.
Okay.
It will be -3.
Yeah, I see. It's here, -3.
So, do you know, this is mean that I can guess from the periodic table directly because I need to make calculation and find the levels and see if it will lose or will gain and check it and something like this. But if I have the periodic table, I can say the charge directly. Okay? So I will look at it and know the charge. I want you to know for me the charge of this one, AS, arisen.
Yeah, this is gonna be the sorry, +3.
+3, why? This is the group 5.
It's the group 5.
Yeah.
Okay, but
It's
but why?
5. It has 5. It has 5. You have $5. To be octet, you need to be 8. So it's easier for you to gain 3 or to lose 5.
To gain?
To gain 3.
Gain
And if
3.
you gain, and if you gain, this is mean -3. Okay?
Okay.
It's not, you see, one time I can erase, other times I don't know how. I don't know how things are going. It's not, I'm not this much smart. Okay, so which element I have to give you? Now again, Abbas, because you didn't catch it. Barium. This one, Abbas.
Barium, it's 2, so it's gonna be the second.
2 plus or 2 minus?
It's 2 plus.
Okay, why?
It's on the second one because
It's a group 2. No, not in the second. It's in
the
group
group.
2. You have to say group 2.
Okay, group 2.
Okay, oxygen.
Oxygen. Where is the oxygen? Oxygen. Okay, the oxygen right there. It's -2, so it's gonna be okay. It's gonna be group 1.
What's this mean?
Group 6.
Yeah. It's
Yeah.
group 6.
Group 6. So it's
very
close to.
important. It's very important to understand it because you have to come to the periodic table and figure it out directly. Okay, let's move. So this is what is written here in this period. If it's group 1, it's what? Positive 1.
It's
if it's
+1.
Group 4 +4. What's plus or minus?
Plus.
Group
5. It's -3.
6.
7.
What is this group 8 noble gases? This is mean what?
It means
Noble gas.
it's a full octet and it doesn't need to gain or
Lose
lose.
electrons. Okay. Ionic compound. Ionic compound are compounds that made up of positive and negative ions, usually formed from metal and non-metal. Okay? These elements are not attached to one another. They will not be attached because it's very easy to dissociate them. Let's take example. Do you see sodium chloride, calcium bromide, potassium iodide? Okay. Can you go to the periodic table, Abbas, and tell me sodium, what was the charge of sodium?
The sodium is the charge there. You can find it and see. Okay, it's right there. It's gonna be -1.
Hmm. It's a
Table
group
7, group 7.
It's a group one. It's a group one.
Okay. I couldn't find it.
Okay. It's a group one. Chlorine
Oh,
is
it's
which group?
+1.
Chlorine which group?
One.
Chlorine which group?
It's group 7.
Okay, so what is the charge?
The charge is -3.
If it's a 7, this is
Oh,
mean
sorry. I mean
-1.
-1.
yeah. Okay.
That's one.
Charge will neutralize, but here it's mean number 1 and here mean number 1. Okay? So one will go here and one will go here. How it will be? Sodium, chlorine. Did you understand why? Plus and minus will be cancelled. And one will go down here. And this one will go down here. But one and one will not affect. Okay? Number 1 will not affect. Because I have number 1 here and number 1 here. And the rule says don't show the number 1. You don't need to write the number 1. Okay? Is it clear? Calcium bromide. Yusuf, please.
So I'm just searching for calcium.
Yeah. Calcium is in the second group.
Second. So it has a -2 charge.
How? It has 2. So what is easier for her, to gain or to lose?
To lose. So
So
it's sorry, yeah, it's +2
please, okay.
because it's losing 2.
Yeah. And bromine?
Bromine is
7 -1.
is it
Group 7.
can't find it.
It's in the group 7.
It's the halogens.
Oh, it's Bi. It's not Br. Oh yeah, I found it. So it has a -1 charge.
Very good. So now tell me what will happen. Positive and minus will disappear. Yeah? Will
Yeah.
neutralize each other. Calcium will go
So
from here, and this will come from here to here. Okay?
so we would write it as CaBr2.
Yes. Now, Abbas, aluminium, oxygen. I will not say anything anymore. Aluminium, oxygen. I will give you space. Yes.
KAl. Oh,
Yeah.
okay, just let me find it. Okay, so the aluminium, it has group 1, 2, 3. Is the fourth group, and it's gonna be the -3.
Aluminium
For
minus 3. Please go back, to the periodic table and check aluminium. I will not help. It's in which group? Mama, why I cannot erase? Well, look, this is a pencil and this, oh, this is here and this one another.
Sure,
Sometimes
it's a +3.
+3. Okay. Don't erase.
So,
Yeah, it's a +3. What about oxygen? Fast, fast.
oxygen, it's -2.
Huh? It's a +3.
And the oxygen is -2.
This is plus 3. And here, oxygen?
-2.
Minus 2. Okay, so now,
-1.
the plus and minus, I don't need them. They will neutralize each other. I will look at the 3 and the 2, okay?
Okay.
What will happen? This 3 will what happen for air?
It's losing.
It will go sliding, sliding, sliding.
And the oxygen
Okay. And here, it will slide.
to the
Yeah.
aluminum.
And so, how to write it?
So it's gonna be Al.
Al.
-2.
No.
I'm not mistaken. No.
We don't use the minus on the positive. They neutralized. They make neutralization. Do you know what is the meaning of neutralize? This is mean plus or minus will disappear. They are not
Okay. So it's gonna be ALO.
ALO.
Yeah.
Okay, that's okay. ALO. What about these numbers 3 and 2? They slides. Do you see the sliding? They are playing.
Yeah. It's not
It's at the top of the slide and went down. So now it's now here. And this too, it's sliding and it's now where?
down for
Yeah.
aluminum.
So what I should write beside the AL?
You're gonna write the 1. No, it should be the same. It's gonna be.
Yeah. It's look here. We are playing sliding. Okay. Here you are, Abdullah. Yes, Abdullah. Here you are. So when you are going here, I will find Yusuf. What I will find?
No, it's gonna be the same. It's gonna
Okay.
be the same. So it's gonna be
Okay.
-2. Still the same.
It will be 2. I don't look the minus and positive in crisscross will disappear. There is no minus. The minus will not go down. Okay?
Okay.
It's
Down's
as
gonna
you
be.
feel. You will leave your fear up and go by yourself down. Okay? And here, the 3.
And for the oxygen, it's gonna be 3.
Yeah, very good. Okay, now let me go to another one. Okay, definitions. Shows the kind and numbers of atoms in the smallest representative unit of substance. Okay, I will give example, and now Yusuf is gonna say these definitions. Simplest. Okay, so I will give another example. I will give, even I will not read it.
So like the sodium chloride?
No, I will give something else.
Oh, okay.
This is I give. Look at it.
Mm-hmm. So you need the charge?
Yeah, what is the charge of the, what is this? I will not read it. You have to read.
So this one is calcium,
Very
Ca.
good. Yeah, so the charge.
I'm just searching for it. So it's in the group 2.
Yeah.
So it has a charge of 2+.
Yes, very good.
And the second element is oxygen.
Yeah.
It's in sorry. This one has a -2.
Yes, very good.
The oxygen has -2.
Yeah. Now what will happen? The
Now,
minus, the positive, what will happen for them?
they're gonna neutralize, and
I don't
the 2 is gonna. So we're gonna write them as calcium 2, oxygen 2.
read the definition.
Which one?
The definition shows the kind
Shows
and
the kind and numbers of atoms in the smallest representative unit of the substance.
okay, so this is calcium, it's okay in this one. This is 2 and 2. Are they divisible?
Sorry, what?
Are they divisible on any number?
Divisible?
Divide, yeah,
Yeah,
on
it's on like 2,
on 2. So,
so they're 1. No,
okay.
yeah.
When I see the numbers are the same, so as if they are not here, I will say it's okay. Let me divide by 2. It's a plus 1. And here, let me divide it by 2. It's minus 1. Okay?
So they equals to 1, so we don't write the
Yeah.
subscripts.
Now, Abdullah, I will give you one as this example. Let me go here. We are here. What is it? Oh, it's not going. Why? Okay. Abdullah, can you explain this is for me?
The example
Yeah.
or
Yeah, the example.
okay, so just let me figure out something. So the calcium is already on the second group, the group 2,
Mm.
and it's 2
Yeah.
for the
Calcium is 2 plus.
calcium,
This is
2 plus.
molecular. Okay. This is molecule carbonate. You will not find it in the periodic table. I already uploaded on the Google Classroom the molecules, so you will see it. You will find it there. You will search about it. Carbonate is written this way, and here there is 2 minus. Okay, I will accept. You have just to memorize it later. Not memorize, just to know how to use it. Okay, so carbonate is 2 minus. This is as one atom. I will look at and treat it as one. So how it will be?
So the -2 is gonna be, or is gonna be slided down there for the calcium, and for the carbon, this here is gonna go slided. So it's gonna be Ca2,
Ca2.
and the other is gonna be CO, sorry, 3 plus 2.
Okay, but they are the same number. Before I start, what I should do? Cancel them. Okay, now this.
Cancel.
Okay, this is for you, Abbas, also.
Okay, aluminum. Where
Yeah.
is the aluminum? Okay, the aluminum, it's positive 3. It's plus 3.
Very good.
Okay, it's gonna be 1, 2, 3. It's the fourth group. The nitrogen.
No, it's not in the 40 group. It's not in the 40 group.
It's not.
No, no. It's not. It's not in the group of carbon. Carbon is in the
Oh,
40.
the nitrogen, it's -3.
Yes. Yes. Very good.
And it's gonna be
Group
slided
5.
as,
It's in group
yeah,
5.
it's in group 5, the nitrogen. It's gonna be Al3 and 3.
Okay, what will happen? This is 3 and this is the 3.
It's gonna go, so it's gonna be Aln. So it's gonna be nutrition. It's not gonna change anything.
It will be, this is the same number and this is same number, 3, 3. So it's easier for me to cancel them. So it is aluminium 1 and nitrogen 1.
1.
Okay.
So it's not gonna.
When they
Yeah.
same number, I have to cancel them. I have to divide them by themselves. Okay. If they are different, okay, I cannot divide. But if I can divide, I have to
The
divide
same
them.
number.
Okay. So how to write it?
So it's gonna be Aln.
Al, and even this is compound, I never saw it before. Aluminium nitride. But anyway, as an